Yes.
So solving trig equations is really the grand finale of what we're going to do in trig. It's going to bring together a lot of the concepts that we've been learning. It's going to use our trig identities that we used earlier in the week. It's going to use our knowledge of the unit circle. It's going to use random facts about crocodiles that you learned about in the 5th grade and your knowledge of quotes from The Office. So first, if we only have one trig part, just a few hints here. If there's only one trig part, we're going to isolate it, kind of like if we had like a square root function, and then use our inverse trig functions to solve. So that happens sometimes. If there are more than one trig part, so if you've got like cosine and sine in there, we're going to use an identity to make them the same. And there are a few exceptions to that, but that's pretty much what we're working with. One trig function, isolate it. More than one trig function, see if you can get it to be one trig function. So starting with this first example, we do have only one trig function. We've just got cosecant. So this is the type that I'm just going to start it by trying to isolate that cosecant. So just like I would if it was just x or, I don't know, radical x, something like that, I'm going to add the 2 over, divide by radical 3. And for most trig equations, at some point, I'm going to use my knowledge of the unit circle. So at this point, we might notice, okay, I don't know anything about 2 over radical 3, but also I'm talking about cosecant, and I don't really have things memorized about cosecant. So once I have that cosecant by itself, if I change that to sine, and then take the reciprocal, because these are reciprocals of each other, we'd have to flip the other side as well. Now that I have sine x equals radical 3 over 2, that's something that I recognize. And also notice that it wants answers in between 0 and 2 pi. So when sine is positive, I've got two different quadrants that it could be positive. So I'm looking at sine in the first or the second quadrant because that's where sine is positive, it's where y is positive. And then I would have to know that my reference angle for radical 3 over 2, that means that x has to have a pi over 3 reference angle. So in the first quadrant, it would be a pi over 3. But a pi over 3 reference angle in the second quadrant would be 2 pi over 3. So bringing in not only our knowledge of radians, which quadrant sine is positive or negative, our unit circle to know what the reference angle is, our reciprocal function to know that cosecant is the reciprocal of sine. I'm telling you, it's a treasure trove of trig. Okay, so our next example, we do have more than one trig function. Got sine and cosine involved. So the hint that was at the top was just to try to get it to be one trig function. So I'm going to use any identity that I can in order to rewrite this to where it's just in terms of sine or just in terms of cosine. And honestly, it usually doesn't matter which one you choose. We're just going to choose one and go with it. So I'm going to go ahead and replace cosine. And remember that our way to replace cosine, because it's a cosine squared, I'm allowed to replace it using one of those Pythagorean identities. And since we know sine squared plus cosine squared equals 1, that means that cosine squared is 1 minus sine squared. So just subtracting that sine squared over. Now I'm back to my original MO of trying to get that trig function by itself. So even though I've got sine squareds, I'm still going to try to get all the sine squareds on one side. So distributing the 3, and then adding the 3 sine squared to the other side. So I've got 4 sine squared. Dividing by 4. Okay, so now I've got the sine squared by itself. Rules haven't changed here. If I'm trying to get sine by itself, that means I've got to square root both sides. And what happens when I square root both sides, when I choose to do it, I have to have that plus or minus. when I take the square root of this, I'm going to have the square root of 3, but then the square root of 4 is just 2. So I've got plus or minus the square root of 3 over 2. So this ends up being kind of similar to the last one, except for the fact that I have this plus or minus. So that means since I'm dealing with 0 to 2 pi, there are going to be 4 different places that I have a plus or a minus radical 3 over 2. I will have my pi over 3 and 2 pi over 3 from the last answer. Those will be my positive cases. But then I also have the third and fourth quadrant where I have the negative cases. So that's going to bring in my 4 pi over 3, and 5 pi over 3. In our third example, we have a new twist here. Notice that in that angle piece of it, we don't just have an x or a theta, we've got a 3x. So we're not going to worry about that until the end here. It'll change our answers slightly. But since we've got tangent squared, I first want to go ahead and take the square root, trying to get that tangent by itself, just like on the last one. And we'll get that the tangent of 3x is a plus or minus radical 3. So if you're looking back at the unit circle, you can. These are always ones that for tangent, I don't have them memorized. Remember I've talked about before that if we want to do some trial and error to see if sine was radical 3 over 2 times the reciprocal, so divided by 1/2, we can see that this has to be the case where tangent is radical 3. If you tried sine being 1/2 and cosine being radical 3 over 2, we could try that as well, and that's that radical 3 over 3. So since sine has to be that radical 3 over 2, that means we're dealing with the pi over 3 reference angle. So sorry that these are all kind of similar, but they just end up with that same angle. So since we've got our pi over 3 reference angle, this is going to be kind of similar to that last one, where if tangent can be positive or negative, that's going to include each quadrant's pi over 3 reference angle. So that means that this angle, that 3x, so not just x, but the 3x, could be pi over 3, it could be 2 pi over 3, 4 pi over 3, or 5 pi over 3. And now where this 3x comes into play is that I actually do want to solve for x and not just 3x. So with each one of these, I'm going to say, okay, if 3x could be pi over 3, if I solve by dividing both sides by 3, or you can think of it as multiplying by 1/3, that means that x actually is a pi over 6. Oh, sorry, pi over 9. I can't multiply. So I've got pi over 9 is the actual answer for x. Same thing when I say 3x equals 2 pi over 3. If I divide both sides by 3, I'm going to get x is a 2 pi over 9. And we can see what's happening with each one of these. I'm going to end up multiplying by 1/3, so each denominator will end up being a 9. So I'll have 4 pi over 9 and a 5 pi over 9 for the actual answer for x. That way, when I plug in 5 pi over 9 for x, I actually end up with a 5 pi over 3 for that angle. Alright, so our last example involves factoring, and you might notice that just from the way that it looks, it is a trinomial. So first, I want you to just pause the video for a second and see if you can factor it. Go for it. So you should have chosen to factor it into a 2 sine of x plus 1 times sine of x plus 1. Remember, even though it has that trig function in it, this is really no different than factoring 2x squared plus 3x plus 1. So if you want to pretend that the sine x's are just x's, it works the same way. Now that we've got our two factors, we're just going to be setting each one of them equal to 0 and solving. So we're going to set this equal to 0. So they both turn into that first type of equation where we just have one trig function, we're trying to isolate it, and then decide using the unit circle what angle would give us that ratio or number. So go ahead and try both of these on your own. See if you can get that sine x by itself, and then decide what angles are going to give you that value. So for the left equation, we get that sine of x equals a negative half, which we know since it's negative, that's happening in the third and the fourth quadrant. Our reference angle when sine equals 1/2 is a pi over 6 reference angle. So in the third quadrant, we should have a 7 pi over 6. And in the fourth quadrant, we should have an 11 pi over 6. For sine of x being -1, that only happens once from 0 to 2 pi. And if we need to draw a unit circle, something like that, to see where sine of x is -1, remember that our sine is just y. So it's happening in this spot right here where our point is 0, -1. And then we would just have to know that in radians, that angle right there is 3 pi over 2. So we've got 3 answers here. Well, I know that you're a boy. I know you're not a girl, but it's a bit that we're doing. You're Jessica Day in this one. Okay. Do you have any polka dots that you could wear?